So, hello and welcome again to another PCB overview video. Today again a motherboard, and today we're gonna take a look at the Z370 AORUS Gaming 5, my daily motherboard from, well, my daily system running my i7-8700K. So, and yeah, there's a few interesting things about this motherboard, specifically its VRAM. So, I've made a video about the X370 Gaming K7, which runs in my test bench system, which is running my Ryzen 7 1800X. This board right here is significantly less powerful than that one. Well, this is a Gaming 5, the other one is a K7. But like, this board is very, very much less impressive actually. So the drop down kind of feels like it's a Gaming 3 actually, but yeah. So what we have right here on the motherboard is, let's just get right into the VRAM, because I just want to get this out, and then after that we're gonna take a look at other things. So the VCore VRAM is a 4-phase. So if you look up, I think it was Hardware Lux, they have a list of pretty much every LGA 1151 socket motherboard and its VRAM. Same goes for AM4. And there they will tell you that this motherboard right here has a doubled 4-phase for VCore plus 3 SoC. And from what I'm seeing here, I actually believe that this is wrong. The VCore VRAM is not a doubled 4-phase, it is just a 4-phase. So the thing is, our PWM controller is right here. That is gonna have the data sheet. Gonna look at the data sheet right now. Yeah. So this PWM controller right here is an Intersil ISL 95866. This PWM controller is a 4+3 phase PWM controller. So you have your 4-phase VCore and your 3-phase SoC. Now, if you have a 4-phase PWM controller, to turn your VCore into 8 phases, you're gonna need doublers. And if you look at this right here, you see MOSFETs and some very, very tiny driver ICs, and only 2 of them, which, yeah, are these even drivers? No, they might be dual drivers, I don't know. No, they have to be dual drivers, but they still would be only driving 4 of the 8 phases. So there's nothing that looks like a driver here, because a driver is, there are some very basic drivers, yes, but like a driver chip normally is not as complex as a PWM controller, but still one of the more complex chips you find on a motherboard. So we don't see one right here. Maybe it's on the back. No, the back is completely empty. There's nothing on the back. So this board, to me it looks like, except I'm missing something, it looks to me like the VCore is just a very big 4-phase. Which, yeah, in theory this board is really, really bad because of that. I've said before that my daily motherboard, I should have gone with the Z370 Gaming 7, not the Gaming 5. When I bought this board, I was torn between this and the Gaming 7, and the Gaming 7 was more expensive, and I looked at the pictures of it and was like, okay, so the Gaming 7 has a VRM fan, and this slot down here is RGB. Yeah, that wasn't the difference. That's not at all the difference. Difference is the VRAM. Very, very much the VRAM. The Gaming 7, as far as I know, is running a completely different VRAM, even a different PWM controller. It's running an 8-phase VCore and a 2-phase SoC, I think. So, yeah, I should have gone with the Gaming 7. This board is not really good. For an 8700K, there are better boards than this. And now I really ask myself, my 8700K is managing some really, really impressive overclocking results. It's running 5.1 gigahertz, 1.35 volts. you can go a lot higher with the voltage on these things, but I'm gonna have to delit it first before, even at this voltage, it's getting really hot. So I'm gonna have to delit this chip, which I'm probably gonna do someday. I'm not doing it today. I do not have a delit die made, and I'm not gonna just DIY something. This CPU is way too expensive for that. So, yeah, so the CPU is getting some pretty impressive clocks for pretty relatively low voltage. And that on this VRM. What would happen if I take a high-end board? Not a Z370, maybe a high-end Z390, which is made for 8 cores, like the 9900K. This CPU might do 5.2 gigahertz at the same voltage, because this VRM, it is, the VRM is not good. The only thing that saves this VRM is that there's 8 physical phases. And yeah, let's get into those phases. So the high side MOSFET, gonna take my data sheet right here again. The high side MOSFET is the hated, at least by me, hated on semiconductor NTMFS 4C10N. You get one of those per phase. Or more like, because it's a 4-phase, you get 2 of those per phase. The 4C10N is a 46 amps max. Where's the continuous drain current? For 80 degrees, continuous drain current is 16.8 amps. That's straight up not good. But this is the high side. Okay, the high side doesn't need to handle that much current. The RDS on is also 6.95 milliohms at 10 volts. These are probably running off of 12 volts, so it's gonna be slightly less. And then the low side. The low side is the also equally as much hated by me NTMFS 4C06N. Again, you get 2 of these per phase if this is actually just a 4-phase. If it's a doubled 4-phase, you get 1 of these per phase. This one has a max drain current of 69 amps, and the continuous drain current at T ambient, or did I say TKs for the other one? It's T ambient temperature 80 degrees. It has a continuous drain current of 23.7 amps. Okay, 23.7 amps times 8 is still gonna be enough for an 8700K. But I think barely. This is discrete MOSFETs on a 14 nanometer high-end Intel CPU. It's just 6 cores, yes, but it's still Intel 14 nanometer. This thing can go to 1.45 volts, and it's custom water cooled, and it's already hitting the 90s at 1.35 volts because it's not delited. Yeah, this VRM, I would not stick a 9900K into this. I'm probably gonna keep this motherboard unless I get like a really, really good deal on some high-end Z390 one. Because like it's fine. It handles the chip 5.1 gigahertz. If I delit it and cool it properly and can go higher voltage, it's probably gonna do 5.2, if not 5.3. It's just the VRM on this board is not good. It's not good. This board does not get a recommendation from me. I should have gone with the Gaming 7, but back then I had no idea what VRMs actually are. I had no idea what makes a good motherboard. I chose this because it was cheaper, and I thought the only difference is one RGB, 3 express slot, and a VRM fan. It is not the difference. The difference is you get a god-awful VRM. Yeah, and that's pretty rough. At least this board is a 6-layer PCB as it appears, because you have on Gigabyte boards you can see the layer count by taking a look here. It's really hard to see, but it does say 6. So this is a 6-layer PCB, which, yeah, if like the cheap boards use 4 layers, so this is better than one of those really, really cheap boards. 6 layer, it could have been an 8 layer. And you're also seeing the memory traces right here, all of the memory traces, which means there's no ground shielding over these traces, which does negatively impact memory overclocking. And memory overclocking isn't that great anyways, because this is a T topology board. Just like the X370 Gaming K7, this is a T topology, and you should be able to see, oh, where can you see it? Gonna have to look, yeah. There are some traces down here. I can't show these on camera, they are too small, but yeah. This is a T topology. So yeah, memory overclocking on this is not that great anyways. And it's not like I'm running some really ambitious RAM in this. It's the RAM I'm running in this right here. This is Hynix AFR. These are 3000 megahertz CL15. This is not anything special, and I'm honestly just completely fine with this RAM because it's Intel. Intel doesn't really need super high RAM speed. Like Ryzen benefits a lot from having high RAM speed, Intel not so much. So that's why I'm completely fine with this actually. And yeah, but I mean, if you would want to buy a board, do not buy this. If you want a Z370 board, go get the Gaming 7, not this. And yeah, so it doesn't really get better when you take a look at the VRM heatsink. So on this at least, the VRM heatsink is one big block that actually has a heat pipe. And you also get okay-ish, yeah, I mean, it doesn't look that great as on the K7, but it's better than that ASUS board we took a look at. So the mounting pressure on this is okay. And the thing that's not okay is just look at this heatsink. There is no surface area. I mean, you do get a heat pipe, but like over the only bit of fins that you have this aesthetic cover, which does have LEDs in it on this side. And yeah, this is not a great heatsink. And the VRM does get pretty hot. It's 85, 86 degrees. Like if you do text to CPU heavily, that's 85, 86 degrees. That's still fine. But it could be better. It could be a lot better. And yeah, this heatsink, it does the job. I'm not a fan of it though. I'm most certainly not a fan of it. Then we can get to another thing, that is the... Oh, where did I put this one? Ah, right there. This right here is the chipset heatsink, which also has an LED in it. It's more like just a metal block that you put onto your chipset. Actually, this one came also with a thermopad like the K7. The problem here is this thermopad tore itself apart. You can see there's a hole there because the part that contacted the chipset just tore itself apart from this. Luckily though, it does look like I can use thermopaste on this, so I'm just gonna switch to thermopaste on the chipset. It should cool it a bit better than a thermopad. But as far as I know, you can even run these without any heatsink, so shouldn't be that big of a problem. I'm still gonna put the heatsink on though. Yeah. And then, so now where I'm done with my rant about the VRM, we can get to the features of the board. You do get a postcode right here. That is nice. I like having a postcode. That is honestly a nice thing. That's a nice thing. If you're memory overclocking, a postcode is very useful. If you do any kind of troubleshooting, a postcode is very useful. So having a postcode is a plus here, and there's a lot of cheaper boards that do not have a postcode. And considering the VRM that's on this, I would, even though it cost me like 220 euros or something when I bought this, I would actually classify this as a cheaper board. But you still get a postcode. That is, yeah, that's a nice thing. You do not get any buttons like the K7, so you can't You don't have a power on, you don't have a reset button on the board. The postcard is pretty much the only overclocking thing you get. Then one thing that I like is right here. I can't show it right now because it's still in the case. This board includes one of these bigger plugs where you just put all your small front panel plugs into, and then you just have one plug, put it into the board. I really like that. That's a nice thing. This makes putting the front panel in really, really easy. And you don't have to look for some tiny inscription on the board, even though it is also here on the board. But that bigger plug also has it written on it. Then another thing that I think is nice is you do get an internal USB 3.1 header, which the K7 does not have. The K7 just has two 3.0 ones. This one actually has a USB 3.1 port. That's also a nice thing. And then also pretty much the last noteworthy thing is you do get this fan header right here, which is a pump header actually. And putting the pump into this, well, yeah, pump header is a pump header, and the pump runs much faster with this header. So yeah, that's also a nice thing. And yeah, like that's honestly pretty much everything. Really, like there's not that much to talk about here. Like I could show you the I/O. It's not that great. You do get Wi-Fi, which actually saved my butt a couple times because our wired internet is really, really unreliable, and having Wi-Fi saved my butt so many times because our Wi-Fi is more reliable. You do get two 3.0 USB ports, two 3.1s. One of those is Type-C. These are 2.0 as far as I know. I don't know what speed these are. These are the DAC up USBs, which are used for if you have like an external DAC for your audio, you're supposed to put this in here. So you get a better 5 volt power supply to your external things. I don't really use it. Like, I mean, I do have an external shuffleboard, but it's not getting powered through this. So yeah, you do have a PS2, which is nice if you do troubleshooting or extreme overclocking. PS2 is a nice thing because like you don't need any drivers for this, and PS2 just always works. USB keyboards and mice can have problems, and then like yeah, you get HDMI and DisplayPort because well the 8700K does include a iGPU. You get 1 gig LAN and your typical audio thing. That's pretty much it for the I/O. And yeah, that's pretty much it for the board. That's a very short video compared to the video I just made, literally just before this, about the card you still see here, my RTX 2080 Ti. That won't wound up an hour long, and I'm gonna do at least 2 parts. But yeah, this is kind of a shorter video. So the VRM on this board is not great. VRM cooling is also not great. In the end, it performs pretty nice because my chip is just very, very good apparently. 5.1 gigahertz, 1.35 volts on a 4-phase. Like, yeah, I mean, people still say, or like where I looked it up, it said it's a doubled 4-phase. I do not see any doublers on this. This is, as far as I'm concerned, a 4-phase, just a 4-phase using double the components. And considering that this CPU is running very, very great, this is running very, very nice for running on a 4-phase. And yeah, so end result, like conclusion to this board is not that great. The K7 was very nice, this one is not. I should have gone with the Z370 Gaming 7, not the Z370 AORUS Gaming 5. This one actually says AORUS, the other one doesn't for some reason. So yeah, and that's pretty much it for the video. Yeah, and hope you enjoyed. Thank you for watching, and until we see each other next time. Goodbye.